Hey class, so here we are towards the last section of the semester, which is now being automated, which we're now talking about in this lecture. The last part is called Future Media Literacies, and it is a 3-part breakdown of what to expect as we enter the future, as what we expect to see in the next decade or 2 or 3. Today's lecture is going to be about the intro to machine thinking, automation, and artificial intelligence. Now, I call it an intro because there's a lot to unpack with this topic. For obvious reasons, there's so much embedded within it. So really what we're going to go over is just some generic terms for the industry and what those things actually do when you hear those terms. And then in the next 2 different lectures we're going to talk about is machine intelligence, and then beyond that is robots. So it's a good way to kind of end the class is thinking about robots. For this one, we're going to be talking a little bit more about the vagaries of it, a little bit more about the industry itself of machine thinking, and what it means to you, and what it means to your future, and what it actually means to data. I mean, it has a lot of understanding in like what it means as a human being inside of this environment. And so, first things first, what is artificial intelligence? You've probably heard that term, AI. You hear that quite often. We use AI, we interact with AI, but what is artificial intelligence? First thing to remember is it's different than artificial superintelligence. Okay, right off the bat, you have to know there's a distinction. When we think about AI, you have to understand that AI in general is something that's been around for quite some time, and AI is something that you do interact with on most likely on a daily basis, some of you twice or more than once. AI is a problem-solving machine. You have them in your phone, like Siri, or you have them in this weird compact garbage disposal looking thing called Alexa, which is the Amazon Echo. And then you also have devices like Hello Google or so forth. Those are artificial intelligence. And what those are supposed to mimic problem-solving devices. So artificial intelligence is really a way of understanding how problem-solving can take place inside of a digital space. The more generic term for that is machine thinking. That is its actual way in which we call it. Machines think. Now, how do machines think? We hear that term, oh, there's machine thinking. But machines think because we train them to think. So what does it mean then to think? What is thinking? Do you ever think about thinking or how we think? So this is a question that's been pondered for quite some time. This is literally the origin of philosophy. We aren't in class, so we couldn't play the philosophy game on Wikipedia, so I'll just tell you how to play it in case you want to play it. If you're on Wikipedia and you go to any entry, any word you want to look at, pick a word, press it in, then go to the first highlighted word in the definition that's not in the parenthetical. In other words, sometimes there's a word and then there's like the Latin word for it. Don't click that, but click the first blue link right after that, and then click on it and keep doing that, and it brings you all the way down to the base structure, which is usually knowledge or philosophy. One of the two ends up at the bottom because it requires us to understand that everything we know, we thought up. We made it up. We think about it. So to think about things means to concretize them into a reality. It means we have a brain that strategizes how to come out with solutions. So really when you think about thinking, when we actually think about thinking, we understand that our job is to either use it passively, as in operationally, ways of doing your daily work, to having deadlines, doing homework, or we do it in solutions, completing homework. What does it mean to have the right answer? What does it mean to have the wrong answer? How do you know when something is wrong? How do you know when something is right? Those are ways in which we, as human beings, over the course of our lifetimes, have thought. What we've considered a part of our reality is thinking. Someone dictates a set of rules, and we abide by those rules. So how do you know if you've done something wrong? Usually you get disciplined by a parent, a teacher, or so forth. They tell you that you've done it wrong. Now, how do they know it's wrong? Where did they get the concept of right and wrong? Someone taught them, or someone dictates that from above. In other words, I could tell you if you've done something right or wrong because if you've done marginally within the space of the answer, it's right. That's it. But if you've done something that's a non sequitur or like completely made up, like I ask you a question about artificial intelligence and you answer something about checking the mail with crayons, that's wrong because it just doesn't make any sense to the context of the question. but it requires you to think about that. In other words, most of all of our thinking is structured. It is built around a structure of reality that gives us the widest example of what's within that range. The better we think. If you want to become a better thinker, it means to hone in on that. It means to understand how to solve problems or strategize solutions better than you had previously. And so those are things that we don't really ever think about, but we should think about it since you're literally in school, albeit school from home. But why you're in school is to train you not to become educated, but become better thinkers, to think about how to strategize and create solutions for an environment that allows you to, one, hold two opposing thoughts in your head simultaneously, but also to have a conscious element that brings in your humanness to the environment around you so we know we're doing it right. And the better you get at that, the more efficient you get at that, the better you are as a human being to enter either a career, a job, a marketplace, to have a skill set that somebody else needs, or to provide somebody else with that knowledge, which is like if you wanted to enter the education field or if you're in the medical fields and you want to become a nurse, you have to learn something that gets you to the point where you have the ability or the power to give that to somebody else. So you have to think about that in those terms. But we think of those terms in human terms, as in we, you, me, and your classmates. We are human beings. We breathe, we convert oxygen, bring it into our body, it converts and breathes out carbon dioxide. Our brains need air and oxygen to actually operate. We create, every time we learn something, we grow new brain cells, like literally cells grow in our brain to create new neural pathways. If you create enough neural pathways, like those neurons, they eventually touch, and all of a sudden you get a more holistic view of things you've learned before. Some of you may have had classes where you're taking a class lesson or a lecture and it like literally reminds you of something that you learned in another class. And that's what it really means to learn, is that when you take something from one environment into another and you've made a connection. And by doing so, you now know that your neural pathways have become complete enough to create a mesh of thought and process. That, as far as you've been aware, is a very human trait. However, in the last 20 or so years, we've learned how to teach machines how to start doing this, how to have them come up with ideas that help us as human beings become more efficient. That's a term called automation. And automation means taking the human element outside of something that's a redundancy. So if something is a redundant factor in our lives, we should automate it. Now that becomes a very complicated term of automation, because a lot of times when we hear the term automation, it immediately evokes the concepts of jobs. Is my job automatable? Am I in a career where I will get replaced by a robot? And I think that's a genuine concern. It's become such a genuine concern that very often a lot of our critique of immigration and a lot of our critique of othering comes from automation. People's anxiety about losing their jobs to robots often can't be blamed on a robot because it's hard to blame a non-living species for some of our capital problems. So instead, what we do is we use scapegoats like immigrants. So a lot of times when you hear arguments against immigration, it's actually just a scapegoat for automation. Now that obviously gets more complicated. This is an intro course. If you want to get more knowledge of that, I think the idea would be to take like a class like civic engagement or really look more into what that means in terms of political ideology. But what you really need to know is that automation is the concept of training a machine to do the thinking of a human to make the outcome more efficient. So when we think about how to train a machine, how do you get a machine to think? So let's talk about that really quick. So let me tell you how you've taught the machines to think in the first place. And I think it's important to understand that we are all, you, me, and everyone, we're all complicit in training machines to be our automated replacements. In the next few weeks, as we break this down, you're going to see some of the major systems in which that have become automated. One of the most interesting ways that we train a machine is training a machine to read or training a machine to do something. So let's use two examples. First, let's use Project Gutenberg. So Project Gutenberg is Google's automation system of the digitization of 95% of the world's written material. The world's written material. So the world, Earth, is a lot. There's a lot of written material. And Google won a lawsuit that allows them to digitize up to 95%. They're not allowed to digitize 100% because then they'd have a monopoly on knowledge. So they're limited to 95%. Like, that makes a difference. So now, when you come across an ancient illuminated manuscript, previous to the printing press, people would literally scribe, they would handwrite the Bible, they would handwrite texts, and somebody would have to be able to read that. Now, human beings have the ability to understand context. In other words, if you're reading somebody's messy handwriting, you can read around the words that you don't really understand and kind of get what the word is missing by the context. And I'm going to take an educated guess here that at some point or another, you've written down something that's so unbelievably difficult to read that you had to reread your handwriting and figure out what the hell word you wrote. So that is, you as a human have figured that out through some sort of nuance and context of handwriting that has allowed your brain to cognize like what it means to read something in its body of work. In other words, the words don't sit alone, they sit within the thing. Now, what if you have to train a machine to read your handwriting? How would they do that? Well, they would have to learn how to write in terms of how many thousands of people write words. So it has to recognize a letter in all of its possible variations and forms. So it could do that to an extent. A machine, you could write an algorithm. So one of the things we'll be talking about next week is algorithms as well, a little bit more. But you could write an algorithm that kind of detects every variation of the letter R, so to speak, or Z, like risotto. Figuring out how the many different ways somebody will write a letter, no matter how scribbly it may be. And if you see every type of variation, a machine might be able to detect through an algorithm what A's are, what B's are, what C's are, and so on and so forth until it comes up with the word. But once you write a word, it brings a lot of those letters together and they don't look right because they're connected to other letters. So then it needs help. And the way you help a machine is you train a machine to think. So, one of the ways in which you've trained a machine to think is something called CAPTCHA, C-A-P-T-C-H-A, which is, I am not a bot, which is ironic. So sometimes you'll go on a website and it'll say, put in your password here, do this, and write down that you're not a bot. So you need to tell me what this word is. And it's like a little silly word, like a bunch of different letters. Now, what you didn't know is that string of silly letters are likely pulled directly from a manuscript, from one of Project Gutenberg's pieces of work, or something along that line. And by you typing that letter, you might think you're the only person typing in those sets of letters, but you're not. You're one of thousands of people typing those in. Now, some of you might get it wrong, and it doesn't block you from getting to the website. It just gives you another bunch of letters to look at, and then you do it again. In time, many thousands of people write the same letter, and the machine learns that variation on that print because it learns from you participating in its mind how to understand that type of symbol as a specific letter or a number. So it got used to it. So if you have thousands of people helping a robot, and I'm talking about a massive robot, something on the scale of a cloud, meaning hundreds of hard drives working simultaneously, it can learn and then automate the process. Because in the end, the goal isn't to sit next to a machine and be like, the machine go, what's this word? And you go, oh, it means best. What's this word? Oh, it means Malloy. I don't know. It's just a word. It means not having to interact with the machine whatsoever. And you put a document down, it's all in scribbles, and you lift it up, and it's OCR'd. It's converted into text. It's text recognized. It turned into text. It turned into data. It converted written text into mechanical mathematical data. So you taught it. You trained the machine to do that. So now let's use another example, self-driving cars, which we're going to be looking at next week or the week after when we talk about robots, because the self-driving car is a drone or a robot, depending on how you want to look at it. When it's a robot, you need to train it to not do something bad. In the case of a self-driving car, I think the main concern of self-driving cars is it doesn't run somebody over. Okay, so how do you train it to make sure it knows that? Well, there's different ways. Now let's talk about CAPTCHA. Sometimes you go to CAPTCHA and it says, identify all pictures with stop signs in it. Identify all pictures with a sidewalk in it. Identify all pictures with a crosswalk in it. The reason you're doing that is because if tens and thousands of human beings can identify a crosswalk, the machine will learn what a crosswalk is. In every type of variation it is. The pictures that machines use, or cars use, self-driving cars use to identify these things are taken from like Google Earth, Apple Maps. They're 360-degree LiDAR displays. LiDAR is the laser spinning thing on the top of the car, which next week we'll go into, that allows you to see the space in 3 dimensions. And by identifying the environment around you, it has to then figure out what are the things inside of it. So once you get past the objects, the still objects, then it has to get to human beings, all the variations of human beings, from people on bicycles to people in baby carriages to people in wheelchairs. It has to know every variation of reality in order for it to learn. But it needs your help, because a machine doesn't exist in reality. It exists through your reality. And that's something that I don't think we often think about, is how does Siri and Alexa know what's going on? If they have no eyes, where are their eyes? What are they looking at? One of the ways that we can interpret Siri and Alexa is that they interpret reality through our queries. Every time we ask Siri a question or we ask Alexa a question, it learns ways in which we ask questions. Because its job is not to give you the answer, but to lead you the proper way. In other words, a machine's goal is not to come up with a solution, but a strategy for you to get the answer. A machine is not to automate the goal, but to find a way to collapse the center of the process. The strategy between the beginning thought and the solution is what a machine's thoughts are supposed to do. It's supposed to collapse that environment. For homework, you're going to watch probably my favorite movie, the movie Her by Spike Jonze. Now, the reason why I show it to you at the beginning here, rather than showing it to you at the end of this, is because I think it does open our minds to the ways of thinking about robots and thinking about the way the singularity will happen. And there's a new word for you. We're not going to unpack that yet. But the movie Her takes place at the moment of the singularity. And to make that very short so we don't have to unpack it, the singularity is the moment in which we give life to an intangible machine, a machine being many, many parts of inanimate objects, a consciousness. If we are able to give a robot a consciousness, that's the moment of the singularity, and that stands for a physics term in which we have literally no idea what happens after that. So everything post-singularity in science fiction is a big question mark. You can be very creative with the singularity, because once machines think as a conscious human being, pretty much anything can happen. There are all classic sci-fi either deals with the singularity as being part of its plot line, or completely without, because it's just too complicated. It's like literally a binary inside of sci-fi because of the environments and world creation that has to take place. And I'm referring directly to sci-fi here because Her is a sci-fi film. It is a sci-fi drama love film. Now, it is a love story. The movie Her, subtitle is A Love Story. And it is about a man named Theodore. The film takes place approximately, I guess if we were to make a date for it, it's in the 2040s perhaps, maybe the 2050s. And it takes place after the advent of an OS, known as OS1, that is as close to conscious as possible. It is so conscious that it reminds any character that interacts with it of another human being. So in the case of Theo, he meets a robot keeps contact with a robot named Samantha, which names itself. And we'll obviously unpack this film next week, and part of your homework is unpacking this film. Some words to the wise. This is not a film you should watch with your parents. There are several awkward moments in this film that are adult content and would make you very uncomfortable with your parents. That said, if you have a really comfortable relationship with your parents, yeah, feel free, go, watch it. It could be, it's a good conversation starter. Let's put it that way. But in this one, we're going to see what Samantha's job is. And so what we're going to talk about, and one of the questions you have for homework, and my favorite question that I could ask you, because it changes the way we think about the film, you may have to watch it twice if you really, really want to get the right answer, and there is a right and wrong answer for this one, is the movie is called Her, which is a gendered pronoun. So the question of their homework is, who is she? Who is her? Who is the movie about? And what is Samantha? When you watch the film, you're going to get engrossed in the idea that Samantha is this Siri-like being, this chatbot that interacts with Theo, and then he develops a relationship with Samantha. But in the end, you have to tell me who does the her refer to? Is it Samantha? Is it someone else? Tell me what you think the gendered pronoun refers directly to. Because in the end, when we think about Siri, Alexa, or Samantha, something we're going to be talking about in the next few weeks, they are a series of hard drives. Likely in the case of Singularity, a quantum hard drive, which means it works at a higher speed than the speed of the robots we have now. Our current Siri and Alexa are limited by speed. It can only process at the speed in which the hard drive itself kind of operates the throughput of these questions. So it has to think about it. Now, that's always a fallacy too. Something I wish I could show you in class. But if you go to Cleverbot, it's a chatbot that is designed specifically to communicate directly with the user. And so Cleverbot was designed in the early 2000s to be a chatbot, and it basically chatters all day long. All it does is talk. What I want you to do, and go to the top of the link and type in Cleverbot, and you can see how many people are speaking to Cleverbot at the exact same moment. This is important to understand that Cleverbot's communicating with a ton of people simultaneously. And when Cleverbot is speaking directly to the user, it's spending time thinking. It's pretending to think. That's a fallacy. It doesn't take time to think. It does that to trick you into believing it has human-like behavior qualities. It thinks that there is a way that humans can need the time to think about something. So it is actually not thinking, but it is processing in real time. So I want you to watch her, and I want you to think about how Samantha is a product, which is a little weird, but I also want you to think about what role does she play in Theodore's life, and what role does she play in the role of the film, and what role she has in the relationships of the lives, the human lives, the actual heart-beating lives of the people that are surrounding her. And I'm going to use the term her for in this case, but it's not her as in who is she, although maybe it is right or wrong. It's something you have to figure out. So I do want you to watch this film, again, content warning, and think that through. And the next week, what we're going to talk about is all of the constitutive elements of artificial intelligence, machine thinking, and automation as we break these down into their pieces. How do we get from now, this present moment, like 2020 in the midst of the coronavirus, how do we get from this point to the point where Samantha is an actual existing thing? I also want you to think about, is it possible, if this were now, to see yourself or see your friends in the role of how Theodore interacts with Samantha? Is this something that you could see as realistic, or is this something that's purely science fiction? So some things to think about. So for now, just watch that and enjoy it. And next week, we will unpack this even further. So the next several weeks are going to be about literacies, but about literacies of the future. This is now more than ever super, super important, considering we live in these isolated spaces communicating to each other almost purely digitally. So it will be something that we're going to have to interact with more and more as we go into the future. Keep your human body healthy and well, and do your best to stay healthy for yourself, for your family members, and everyone around you. So until next time, be well.